也许相聚忽然变成分离，只能静静等待关于你的消息。也许亲吻只能隔着玻璃。
Hello everyone, my name is Jinzhou Qi. You can just call me Tom. I'm the first year MENG student in the EC department at the Cornell University.
Hello guys, my name is Shangquan Fu. You can call me Oliver. We are classmates, so I'm also first year electrical computer engineering graduate student. Nice to meet you guys.
So first, together we propose our project, the COVID-19 access systems. 2020 has been a tough year. We've all been through a lot. With this pandemic, it has changed our life greatly. And living around the Ithaca areas is super important to keep safe, not only to protect ourselves, but also to protect others. And the project we propose is a COVID-19 access systems, where it can be implemented in the school library entrances, or in the school facilities, or maybe in the EC building front doors. So it can provide verifications to make sure that the visitors are COVID negative and has following the contact code proposed by the Cornell University.
Okay, let me do the introduction about the functionality. So firstly, I would introduce about our handmade COVID-19 access system. So let me introduce the parts we used. So this is the Raspberry Pi with PiDFT. PiDFT is the user interface screen. People can see the information on the screen. This is the camera. So we use the camera to do the face mask recognition. So like it can check whether you have the mask or you not have the mask. So the next one is the human body temperature sensor. It will check your body temperatures through your head. You just use your head to approach the sensor. It will check your body temperature, make sure you are not having fever. This is the fingerprint sensor. It will collect your fingerprint information, then query the database in the Cornell University. It will get information about your Cornell information such as your name, date of birth, net ID, and whether you have the COVID, and also about whether you have done with the survey, then give you the access of the building. So one of the most important feature of our system is the low power mode. We use the human infrared sensor because the system will work in a whole day in the front of the building, but sometimes there is no student in front of the door. So we use the human infrared sensor. If there is no student in the front of the door, then the system will shut down. When some new students come in, the system will work again. So this is how we save the power. Okay, now let us do the demonstration. We have several scenarios in the following.
So when people came in front of our system, we just need to press the button to boot it up. And as you can see, we can see a COVID access system in the PiTFT. And there's a bunch of loading information telling people like what the system is doing. It's either loading the face mask detector and the face detector models. And then the system starts to record the video streams and then start to identify whether the people is wearing a mask or. Since currently our visitor is not wearing a mask, they will show wear a mask dummy on the PiTFT screens. And when the visitor wears a mask, it will show goodbye, and then seeing the visitor is wearing a mask. And afterwards, it will initialize the body temperature sensing modules. Since currently our visitor is far away from the modules, the system will ask the people to remeasure its temperatures, and after it shows the normal temperature for the people, the system will then ask to check the ID for the students. It will ask the people to put the thumb on the fingerprint sensors and then to check the fingerprint information out of our database. After a few seconds, we can see we finished checking and it shows the correct information of the people's name and the net ID. After all has been verified, the system will then let people in. The second scenario shows the visitor is a Cornell student and has a negative COVID test result, but it didn't finish the daily check. And we can see the system shows the correct student information and shows a negative COVID result and says the student should complete the daily check and won't let the students in. This scenario represents a student from Cornell but has a positive COVID test result. The middle finger represents another student, and when COVID is detected, the system will keep the student out. Scenario 4 basically represents the situation when the student is having a fever. We are rubbing our fingers to increase the heat on our fingers so the system can detect a fever, and the system will keep the students out and won't let him in. Last but not least is the low power mode. So if there's an emergency, the visitors has to leave, so the system will shut down automatically after 20 seconds. And we can see from the figure that the light for the fingerprint sensor has turned off and the system will turn on after the press of a button. Thank you all for watching and hope you can be safe and remember to wear a mask. Thanks.